Alright, let's see if I can do the answers for this. Draw it. Well, what was I doing? A copper gold battery, that's right. Cu and Ag. Ag? So that's silver. Au. Gold. Okay. First things first, for any galvanic cell, we want to draw two, what do you call them, half cells. We've got an electrode and an electrode. This electrode can be gold. No, we'll make that copper. This one can be gold. I will do the wire. I will have a light bulb and then do the wire. Here, solution can be copper sulfate. This solution can be gold nitrate. Why not just sulfate nitrate there, spectate on so they don't participate. We need a salt bridge. Going to be like that, and that's going to have I think I said potassium chloride, so I'm going to put the Cl minus here and the K plus there. And now we need to do the half equation. So copper is above the activity series than gold. So copper is going to be the one which is, what do you call it? It's above, so it's going to force its electron, so it's going to oxidize. So Cu solid will become Cu2 plus aqueous plus 2E minus, and silver is a 1 plus ion, so this is going to come out of solution and plate, so it's going to be Au. Pretty sure gold's a 1 plus ion. Gold, common ion. I don't do many chemical reactions with gold. Yeah, I thought so. Au plus. I just had this feeling. Au plus. It is plus. It's a 1 plus. So Au plus aqueous plus E minus makes Au solid. And of course, anyone who's trying to take the gold back is going to be very, very happy because their gold electrode is going to get heavier and their copper electrode is going to get lighter. And so also the copper gives away 2 electrons and they're going to go up here. So the electricity is going to flow this way and then down here. And for every copper that goes off into solution, 2 golds are going to plate. Now, as the gold comes out of solution, so the Au plus will come up and plate onto that electrode. The K plus will come down to replace it out of the salt bridge, so that it replaces the holes created by the positive ions disappearing from the gold nitrate. And the chloride ions, as the copper comes off and becomes copper 2 plus in solution, they're going to come down the salt bridge this way. They're going to what we call migrate down the salt bridge, and they're going to backfill the additional positive charge that's going to be going into that half cell. So what have we done? We've drawn it. Okay, I've drawn it. I label everything. Well, we haven't labelled everything yet. A couple of things we're forgetting. So, an ox and a red cat. Anode oxidation, reduction of the cathode. Well, this is oxidation, so that's the anode here. And this is where we're getting reduction of the gold, so this is the cathode. These are really messy drawings. I hope that when you're in the test you do a better one. I've just got this tiny whiteboard and it's my shopping list, or my wife's shopping list whiteboard from the fridge, which I wiped the shopping list off and now I'm using it for chemistry. What are we forgetting? What are we forgetting? Anode, cathode. Electron's going to go towards the positive terminal, so this will be positive, this will be negative. Okay, so and I've drawn it, I've labelled everything, I think I've got everything there. Show the minus direction, I've done that, they're going this way. Do the half equations, there's one and there's the other, yes. Show the cell notation, alright, I'll do that. Cu2, no, it's solid this time, that was before. Cu solid, line Cu2 plus aqueous, salt bridge with KCl, and then it's going to be Au plus aqueous to Au solid. So there's the cell notation, show cell notation, show flow of all ions. I'll just recount that the copper's oxidizing, so it's going to come off the solid copper electrode. The copper electrode will get lighter over time, and it's going to go into solution. So you're going to get Cu2 plus ions coming out into solution. And over here, Au plus, the gold's going to actually go and plate onto that electrode. Now, as the gold plates onto that electrode, it's coming out of solution. It's going to leave holes where there used to be positive charges, and it'll want to balance that. So the K plus will come down to replace it. The Cl minus here, that will go the other direction. That will balance out all the positive coppers that are coming into this solution here. Now the deal is, if you took this salt bridge out, this would become extremely, what's the word for it, like negative in terms of, you know, the lack of, because you've got all these nitrates left over, but you're pulling all these golds out of the solution, so there's going to be all these negative charges everywhere. And over in this one, all this copper is going to be pushing out, so that's going to become extremely positive. And of course, if there's one thing that, you know, these things don't like, it's to either become more negative or more positive, because more positive is going to start to repel the other positive, and the negatives are going to want to hold on to the gold ions that are in solution. So you need to connect it with a salt bridge to sort of counteract the electric repulsive and attractive forces that would go against the battery operating. That's the purpose of the salt bridge. Okay, now I've shown the flow of all the ions. Well, this is very similar to how you'll get a question in the test. It'll be like, this is what I'll give you, this bit here. I'll simply give you the notation. I'll say, draw it, label everything, show the minus direction, do the half equations, show the cell notation, and show the flow of all ions. And it's like a half-page question. And all I've got to do is pick two metals that are in separate locations on the activity series. That is the answer to the copper-gold battery.